Alright, so welcome back. We're on to chapter 8. So now we're going to talk about the appendicular skeleton. So this will be very simple too. It's going to be a lot of repeat from lab. So just kind of take it as maybe an opportunity to clarify some of the things that maybe you didn't understand in lab, or just the opportunity to hear things again. Sometimes it's always good to hear things twice, right? Alright, so on we go. So when we're talking about the appendicular skeleton, basically we're talking about our arms, our legs, our shoulder blades, and then our hips, right? So the things that are going to attach our arms and legs to the actual vertebral column. And really it's there to help you move. And I want you guys, if I haven't asked you to do this in lab, I want you to think about this. Think about how your upper appendicular skeleton is very different than your lower appendicular skeleton. Think of how it's actually attached to your vertebra, right? So up here we have a scapula, clavicle. Down by our hips we have this fusion between the ilium and the os coccyx, that sacrum. So it's a real strong sort of connection down in our pelvic girdle versus our pectoral girdle. Why do you think that is? And, by the way, this is true for even four-legged animals. It's the same thing. If you said mobility versus like structure and power, you're right. So basically our pectoral girdle is allowing us to move and reach, even for animals, right? Animals they reach with their front paws, right? So it gives them flexibility. Versus our hindquarters, even for us when we run, that's where we get our power from, right? And for that, you need a really strong structure so that it's keeping you, again, kind of together, of being able to absorb all that shock. And you think of when you jump, it's really important that your legs will, excuse me, suddenly dislocate and you find them up by your ribs or something. That'd be horrible. Again, same thing for animals. When animals, the power quarter of animals, including horses, is their hindquarters. That's where they're pushing from. Okay, so that's the key difference. It's the compromise between mobility, right, and power. All right, so with that, again, I'm going to hide me so you guys can have a better view of these images. Okay, so again, you can kind of see this here. It's pretty clear, and we have these really deep sockets in our hips. Again, that fusion for that power, that real strength. And then here in our arms, very shallow sockets, muscle attachments attaching our pectoral girdle to our axial skeleton, again allowing for the greatest mobility. So our pectoral girdle is going to consist of our scapula and our clavicle, again held in place by muscle only, and our humerus is going to attach to that via the glenohumeral joint. We take a look at the clavicle, right? They're basically sort of an S-shaped bone. So here we have a superior view, so kind of looking down. And here we have an inferior view, excuse me, looking up. So basically, this is going to extend from the sternum to the scapula just above the first rib. And one of the interesting things is the structural weak point is, so you see this curve right here. Here's the other curve from the sternal end, and basically where these two curves come together is where it's often fractured. So a lot of times when people fall, they put their hands out in front of them and they kind of stiff arm it. When they stiff arm their fall, that shock travels up their arm and it ends up breaking their clavicle. Okay. It also tends to be a classic injury. A dislocation of the clavicle is a classic injury in wrestlers, and sometimes that results in what's known as a piano key injury. I'll kind of just put my image back on so you can kind of see this a little better. Right, so your clavicle kind of comes like this, and they call it a piano key injury because depending on whichever end, sometimes they'll just kind of stick up, and you can play it kind of like a piano key. Anyway, a little bit of a tidbit for you. All right, so let's just go over a scapula. So here's the anterior surface. Again, here's the view. We're kind of looking straight back through the ribs at the scapula. This large subscapular fossa is filled with a muscle. I'll give you a hint, it's called the subscapular muscle. Some of these would be really easy when you get to muscles. We have this coracoid process. Excuse me, it's there for muscle attachment. So part of your bicep is going to be attaching to this coracoid process. Okay. We have the acromion process as well, and we have the different borders. Remember, the borders are just telling you whether or not they're on the side versus the middle versus the top versus bottom. Okay. Here's a posterior view. So here's the spine of the scapula. Remember that spine of the scapula is going to end in that acromion process. Above the spine would be considered superior to the spine. So that is called the supraspinous fossa, right? Shallow groove. Underneath the spine would be inferior. So that fossa that's inferior to the spine is simply called the infraspinous fossa, right? So that should hopefully help you with that. Base that shallow groove where your humerus, the head of the humerus will be sitting, that's called the glenoid cavity. Sometimes it's also called the glenoid fossa. Okay. And also the supraspinous and infraspinous fossa will also be sites of muscle attachment. Just like the subscapular fossa, it'll have very similarly named muscles. So pretty much you know, in the supraspinous fossa, it's the supraspinous muscle. It's also called the supraspinatus muscle. In the infraspinous fossa, it's the infraspinatus muscle. Okay, so pretty simple there. Excuse me. All right. Our upper limbs, so our arms, have about 30 bones in them. I always say about because it always depends on whether or not you're going to consider some of these little sesamoid bones, and you'll have those little floaty, like round floating bones in your joints, like in your fingers and stuff. So it depends on whether or not you count those. Anyway, your humerus is in your arm, ulna radius in the forearm. Please, 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 please make sure you are clear on that. Humerus, arm, ulna radius, forearm. I know in everyday speak, we call the whole thing our arm. However, in anatomy land and in biology land, nursing land, any other land that's dealing with healthcare, the arm is simply this upper portion, and the forearm is your forearm. Okay, we do distinguish between the two. You have carpal bones in the wrist, metacarpal bones in the palm of your hand, and then the phalanges are your fingers. Okay? So at your shoulder, you have your glenohumeral joint, obviously your elbow, your wrist. You have metacarpal phalangeal joints, right? So in between the metacarpals and the phalanges. And then the joints within the fingers themselves are your interphalangeal joints. All right. So your ulna is on the little finger side. Radius is on your thumb side. Remember, radius is rad. Thumbs up, man. That's rad. Radius is thumb side. You have that notch in the ulna. That's the trochlear notch. Articulates with the trochlea. So let's see if I can get my pen going here. So here's this trochlear notch. Here's the end of the humerus. Here's that trochlea. So you can kind of see that trochlear notch just kind of curves around it. Okay. The radial notch, the radial notch right here in the ulna will articulate with the radius right here. Okay. The olecranon process forms the point of your elbow. Okay, so again, if you give someone an elbow in the face, because I don't know, you're not happy that day, MMA kind of thing, an olecranon process right in the face, you've just elbowed someone in the face. I'm sure that's a way to like really get people to be really mesmerized by how smart you are. When you're watching MMA next time and someone elbows someone else in the face, you go, ooh, they took an olecranon process right to the mandible or whatever. All right, bad jokes. Okay. Again, radius, thumb side. The head of the radius is going to articulate with the capitulum. Right, so there's a little capitulum. And the head of the radius will also articulate that radial notch of the ulna. Okay. We do have a radial tuberosity. It's there for muscle attachment. Again, it's going to be a site of attachment for your biceps brachii muscle. Okay. In your wrist, you have carpal bones. Now, you do not need to know these for your lab practical. However, I would highly recommend that you learn them. These will come up in any kind of healthcare situation. Wrists are constantly being injured. You will have to memorize them. So I would memorize them now. Okay. So in your proximal row, you have your scaphoid, your lunate, excuse me, your lunate, your triquetrum, and then your pisiform. Okay. And then in the distal row, you have the trapezium, the trapezoid, the capitate, and then the hamate. Okay, so that's sort of the order that they go in. And then here's just a little mnemonic to help you guys try to remember that. In the wrist, these bones, they have sort of a little bow to them. So that allows, and then you also have this ligament called the transverse carpal ligament. That creates a space. That is what your carpal tunnel is. You've all heard of carpal tunnel syndrome. In that little space between that ligament and the carpal bones, you have lots of tendons for the fingers, for your ones that are going to flex your fingers. And then you also have the median nerve, which sends signals to your fingers. Now, basically what ends up happening is you have inflammation in the carpal tunnel, and basically that inflammation causes swelling, and then you have pinching in this medial nerve. You have muscle weakness and pain. So usually what they'll do is they'll simply take that transverse carpal ligament and they'll cut it. And that alleviates the pressure, and basically no pressure, no pain, you're back to functioning. All right. Let's take a quick look at the pelvic girdle and our hip bones, right? So our two os coxa are going to fuse at the pubic symphysis, and then posteriorly they are articulating with the sacrum, right? And at that point they're called the sacroiliac joints. So each one of those os coxa consists of the ilium, the pubis, and the ischium, and all of those are going to fuse shortly after birth at the acetabulum, right? So here's our os coccyx. Here's a nice view. Your ilium is kind of on top. The ischium here is in this pink in the back, and then the pubis is in the front. There are differences quite pronounced between male and female skeletons. Male skeletons tend to be larger, heavier. Again, they're going to have larger surfaces for larger muscle attachments. In particular, one of the things that will make the female skeleton obvious is that the pelvis tends to be wider and shallower. And then basically, well, I'll show you what this is in a second. The pelvic inlet and outlet is larger, and that's going to be so the baby's head can fit through. Okay, and this pubic arch will be greater than 90 degrees. Okay. So here on the left, what you're seeing is female. Here on the right, what you're seeing is male. So here you can see the pelvic outlet is much wider, much narrower in the male. You'll also notice this greater sciatic notch in the female is much broader. That kind of pushes out the coccyx, right? The sacrum and the coccyx, again, allowing, because you don't want baby's head to scrape along that thing, right? Much narrower in the male. And then here's that pelvic inlet. Again, it's going to be bigger in the female than in the male. And then here's that pubic arch, again, larger in the female than in the male. So lower limb has 30 bones just like the upper limb. So basically your femur and the patella is usually kind of lumped in with the femur. That makes up your thigh. The tibia and the fibula make up the leg. And sort of similar to what I said about the arm, getting my pen to work. This term thigh is different than the term leg in anatomy land and in healthcare land. I know, again, in everyday speak, we call the whole thing our leg. However, in this case, when we are here in this class, this is the thigh. This portion down here is the leg. Super important. If you tell me otherwise, it's going to be wrong. Please make sure you keep those two things straight. We have, not carpal bones this time, but tarsal bones, think T for toes, they're in the foot, or by the foot. Metatarsal bones are in sort of like the front part of your foot. Some of the tarsal bones are making up the back part of your foot. The phalanges are simply your toes again, right? And then basically we have a hip joint, knee joint, axle joint. Okay. You have joints between the tibia and the fibula, so that they connect at the proximal end as well as at the distal end. And then you have also metatarsal phalangeal joints between the metatarsus and then phalanges. And then of course you have interphalangeal joints as well, so the joints actually in your toes. Okay. So let's just kind of go over some of these structures in the femur. So here is the os coxa, right? The head of the femur is sitting in the acetabulum. We have this greater trochanter, and if you look at this image up here, you'll notice that the widest part, and this will be true for males and females, the widest part is actually this greater trochanter. It's not the hip bone itself. So when you're kind of like bumping something with your hip, like to close a car door because you've got like your arms full of groceries, what you're actually bumping it with is this greater trochanter. Okay. So that's more lateral, the lesser trochanter is more medial. Okay. So on the back part of the diaphysis of the femur, you have that ridge, that's the linea aspera. We're going to see muscle attachments going in there. At the distal end, again, the articular surface, those are the condyles. So the one medial is simply the medial condyle. The one that's lateral is the lateral condyle. And then sort of these little bumps right above them, we call those epicondyles. Sort of like epidermis was above the dermis, and epicondyles above the condyle. And similarly, if it's medial, it's simply the medial epicondyle. If it's lateral, it's the lateral epicondyle. Okay. So patella is a very large sesamoid bone. One of the things it's doing is it's to help increase the leverage. Okay, so it's actually gives a little bit of extra strength to your quadriceps muscles. Okay, basically it's also protecting that knee joint. Let's see if I help. Let's see. So try to draw this for you. So let's see. Here's our femur, right, and it kind of ends like that, right, and then here's the tibia. Right, so if we bend our knee, right, so here's our thigh, right, and then here's our tibia down here. This would be our patella in the front, right? So if you'll notice that when you do that, when you basically like bend your knee, it causes a gap right in here. And if we didn't have this patella in the front, it's easy to imagine how you can damage blood vessels, nerves, all sorts of other soft tissue that's in between these two bones, right? So that patella is there to help protect that knee joint. Because it's constantly gliding up over the femur, it's not that difficult to cause what's known as patellofemoral stress syndrome. So runners, as they're running, it's going up, down, gliding back, forth, back, forth, back, forth. And sometimes if muscles are imbalanced, I should say, so let's kind of get like a frontal view. So here's your patella, as it's gliding up and down, right? If muscles are imbalanced, instead of gliding straight back up and down, sometimes they'll track off to the side, either laterally or medially, depending. Okay, so what ends up happening is it kind of pops out of its sort of little track, and you can imagine that's kind of painful. Right? And it's very irritating, it's inflamed and stuff like that. That's what patellofemoral stress syndrome is. Basically that patella is not riding in its groove like it should, and it's kind of like moving over. And that's causing irritation and usually inflammation. All right. So the tibia and the fibula, let's see. So here's our tibia right here. Fibula is next to it. As you'll notice, the fibula is actually not part of the knee joint. It's simply attaching to the tibia. Basically, let's remember that our medial malleolus is basically our inner ankle bone, and then the lateral malleolus is on the lateral side. And basically, do this, like, this is unfortunately, this arrow does not go with this picture. So this is actually your lateral malleolus here. So this is sort of one picture here. Here's another picture here, and as they overlaid one another, it made it look like it's pointing to the same thing. It's not. Okay, so that's your medial malleolus here on the tibia. The lateral malleolus on the fibula. Right. Yeah. So here you can see. Let's see. What are some of the other structures? We had our tibial tuberosity. Our quadriceps are going to insert into there. We have medial and lateral condyles. Those are going to be these articular surfaces. So medial is simply medial, lateral is simply lateral. Okay. So very similar to how our wrist and hands are arranged, so to our feet. We have several tarsal bones that make up our ankle and our heel and sort of like the back weight-bearing part of our foot. Then we have 5 metatarsals that sort of make up the middle front part of our foot, and then obviously phalanges are our toes. So here are the tarsal bones. So basically all of these are tarsal bones. So again, here's the weight-bearing portion. The calcaneus is your heel, and then the talus is the part that's actually articulating with the tibia and the fibula. And then you have several others. Again, this is one of those things where you should really learn these now. It'll make your life a lot easier as you go into any kind of healthcare field. And then here's another mnemonic for the tarsal bones. Something I didn't mention for the hand, but same is true for the hand as for the feet. When we number things, we always start with either the big toe or the thumb, and we work toward the pinky. So basically, here are our metatarsals. So big toe is 1, 2, 3, 4, pinky toe. Right? Same thing would be for your hand. Thumb is 1, 2, 3, 4, 5. By the metacarpal by your pinky. Same thing will be true when you're numbering the phalanges. So this phalange on your big toe will be 1, 2, 3, 4, 5. So it's the first proximal phalange, second proximal phalange, third, fourth, fifth. Now on your big toe, just like on your hand, the big toe and your thumb only have a proximal and a distal phalange. They do not have a middle one. So you simply have a first proximal, first distal. Now everything on this next toe over is 2. So even though technically it's the first middle one, because this one didn't have one, we still call it 2. So everything here is 2. So second proximal, second middle, second distal. Third proximal, third middle, third distal. Fourth, fourth, fourth. Fifth, fifth, fifth. Okay. Right. And sort of last thing, the way your bones are shaped, they form arches in your foot. Okay. The main thing is that this is going to distribute the weight over your foot. So basically this is going to help act as a shock absorber. So there's less shock basically traveling up your legs, up into your hips, lower back and stuff. And it also kind of gives you a little bit of an extra spring in your step, if you will. It helps you return some of that energy back to that motion. Okay. People who are flat-footed usually can't travel very long distances. It can be painful. Okay. Right. So again, you can kind of see you have a transverse arch, and you also have longitudinal arches. Right, so transverse simply goes across like the top of your foot. So basically how your shoelaces kind of crisscross over top. Basically that's the same direction that your transverse arch goes in. And the longitudinal arch basically goes from the back to the front of your foot. Alright, so that's basically it for this section. Let me know, as always, if you have any questions. More than happy to answer them for you. Alright, take care.